Hi, my name is Alec. I'm from Vancouver, Canada, and this is my entry into the 2016 Moog circuit bending competition.
There have been some great entries in past years, but I noticed that everyone I saw took musical equipment and combined it with musical equipment to make musical equipment. I wanted to add something out of left field. What my turbo robot hands are now drawing is a synthesizer, some controls to tinker with, a signal generator to generate audio signals, an amplifier to make it loud, and then a speaker to play it back. A speaker is basically just a coil. My robot hands are now drawing a brushless DC motor setup, again some controls to tinker with, a signal generator to turn it into something the motor understands, that's typically 3 waveforms, offset 120 degrees each, a driver to make it powerful, and then a motor to actually do the work. This motor is basically 3 coils. Looks pretty similar. I'm going to mash these two things together so that each piece of it does double duty. For controls, I'll use a toy guitar from a thrift store. For a signal generator, I'll use an Arduino sketch, but modify it so it generates the 3 signals for the motor control. For the amplifier and the motor driver, I'll use an L293 motor driver chip, and the resulting signals will drive both the speakers and the motor simultaneously through the same wires. To make it less pointless, we're going to stick the speakers on top of the motor. Let's check to see whether a rotating sound source makes an interesting phasing effect. Here's the schematic we're going to build. It's an ATmega 328 microcontroller, the same one used in the Arduino Uno, an L293D quad H bridge for the motor and speaker driver, and a few bits and pieces for power regulation. All the rest of the I/O pins on the microcontroller are used to read the controls and control the LEDs on the guitar. Opening the guitar, you can see there's a bunch of lights, a bunch of switches, and a craptastic whammy bar. If you made the same mistake I did and stuck batteries in this to find out how it worked, you would now do what I'm going to do, which is to cut every wire you can see. We're going to reuse the buttons and controls, but not the synthesizer.
Alright, our first set of switches is soldered. Good, now this sea of wires should give me the opportunity to read whatever's happening on that control panel, control the lights, and so on. So let's breadboard that onto the Arduino and see if we can just read that all those controls are working properly. Skipping a lot of painful steps where I had to figure out why something wasn't working. This is getting pretty close. Alright, so the 3 plugs you see up here are for the 3 little keypads, and then there's plugs on there to hook them up. Then the bottom one here is for a few additional bits and pieces, the 4 lights on there, and then the volume knob. And I've got on here programmers, so there's an in-circuit programmer for this beastie, so I don't have to pull the chip every time I want to put some new code on there. All I've got to do now is wire up this other little board here, add this to the board, which is the motor driver chip, and then we're ready to mount this inside the guitar.
The circuitry is too large to fit inside the plastic case.
I think I'm going to try dremeling CD-ROM into pieces. Never tried this before.
Mounting 3 speakers on a CD-ROM motor.
Yeah, that worked. I melted more than I cut, but let's clean it up a little bit and it should work just fine.
Let's summarize. We took an existing Arduino synthesizer library and forced it to generate 3 waveforms instead of 1, offset by 120 degrees each. We took an L293D quad H-bridge chip and forced it to behave as an audio amplifier while still continuing its regular duties as a motor driver. And we forced an especially crappy kid's guitar to make interesting noises, inspired by the Leslie speaker, but with a distinctly different technological approach. This would be a lot more interesting with bigger speakers, on a more powerful motor, controlled by a better guitar, and powered by a lot more than 9 volts. And that's what I originally intended to build, but could not within the constraints of this contest. I have most of the parts, including this awesome keytar, donated by a very generous Brent. Support me and help make this loud and dangerous. Thanks for watching. The source code, schematics, and plans for this project are available at Cassettepunk.com.